Okay, so now we're going to talk about some features of how to incorporate good design into your Python program. In particular, actually, we're talking about functions and then how that also relates to help files and the design recipe that you'll see used in those help files as you learn to program in Python. So let's see here. Okay, got it to advanced finally. Okay, so there are two different kinds of help-related functions that you can make use of in Python. The first one, dir for directory, is going to tell you what functions are in a module. So right, that you have packages in Python which contain sets of modules, and then modules in Python that has definitions and functions contained in it. We'll talk a little bit more about that later. I don't think I've gone into much detail at this point on that. But this is one way that you can tell what kinds of functions and definitions are found within a particular module. So there's the built-ins. That's kind of the default, the base level functions or definitions built in to your basic installation of Python. You can see it there. I'll show you that in just a moment. You can also take a look at what's in a particular module, such as the math module. This has some functions such as the logarithm and other trigonometric functions, and I'm sure lots of other things I'm forgetting. If you want to know help about a specific function or even a module, you can use the help command function here. And so help ABS will give you help about that particular function. I'll show you this in a moment. Help math gives you function about the math module. You can generally ignore stuff that starts and ends with 2 underscores. This is the magic methods of Python. We'll talk about that later, but for now, just don't worry too much about those. We'll learn about why we have to use these double underscores leading and tailing certain keywords within R that stand for these magic methods. So we're going to talk about what I really want to focus on is talking about the design recipe. But before we do that, actually, let's go back and look at those functions we just talked about on this page first. Okay, so here I've used some of those commands that were listed in the notes. If I use F9, of course, I can line by line go through and run these codes. So if I just run first directory built-ins, here's all the built-in functions. You can see I can scroll up and see all of them. So we have things about errors, all kinds of errors here. Then we get to those underscore keywords. Remember, right now, don't worry too much about these, but you will notice that these are definitely what we would call keywords within the programming language, and that's why they reserve this special notation for them. Now we have a bunch of functions. So ABS, absolute value, any Boolean, all kinds of things that are going to be useful. So if you sometimes need help to remember exactly what the syntax is of a particular function, this could be useful. Okay, so I want to also look at the math module. So first we have to import that because it is a module. So you have to, each time you start a new session in Python, you have to re-import your modules. So I've gone ahead and imported math. Then let's look and see what in the world is contained in math. Well, you can see it's all kinds of things, like I told you before, pi is not installed in the built-in functions, but now that we've loaded the math module, it's there. Floor, the exponential function, trigonometric functions, all kinds of things. Useful stuff. Here's what a help file looks like. And this is going to lead us into the next part more. So ABS, help on a built-in function in module built-in. So this is giving us the syntax help. So it just takes a number X and returns absolute value of the argument. Notice we get a little bit information about what we should be getting, what we should put in as arguments and so forth. That's really important. I don't remember why oh yeah, this is a longer help file, much longer than what we saw for ABS. So this is also a built-in function. It takes an integer, or sorry, a floating point and returns an integer. So right there, we've got some information about what it does. Then we have a nice description. So convert a number string to an integer, or return 0 if no arguments are given. X is a number, then you return X in integer form. For floating point numbers, this is going to truncate it to 0. That gives you some other information. So other methods defined here, and it gives you all kinds of information about these other methods. So you can see this is a far more involved help file than the one for ABS. Okay, so now back to the notes. We're going to talk about making sure we have a good design recipe, and then also why it's important. We're going to, there's steps for writing a function or definition in Python. And these are the steps. You should have an example. You should have a contract with the user of your function so that they know what they need to input and what they should get as output. Then you have a header, a description, the body of the function, and then some tests at the end to make sure it works. So I'd like to show you a couple, well, let me just do one example actually. Going back to this spider window, let's define, I'm going to do something easy here. Let me think. Okay, so I'm going to have a function that converts a Fahrenheit to Celsius. So I did F to C. So that's a pretty easy definition. I forgot to, there we go. This, let me start with this. This is going to take integer and yield an integer. This function converts a Fahrenheit temperature to Celsius. Now I'll have to remember that formula. I think I can. Okay, so a little description of what it's doing. This is a really good idea. You know, I don't know why I did integer. I'm going to rethink that. I was starting with another function in my head and I just carried that through. If I'm converting temperature, that's a measurement level variable. So let's make that floating. Okay. Okay, so okay, so we'll see if I can get this right. F minus 32 times 5 divided by 9. Okay, so I think that's correct. Then we'd maybe do some tests such as maybe this. What should be the result of converting Fahrenheit of 32 to Celsius? We should get 0. Yes. Okay. So let's copy that. Try some others. Let's see, some other easy ones would be something like 212, right? Yeah, we get 100. Good. What about, oh yeah, I'm thinking of all the obvious ones. -40 to -40, right? Okay, so this is an easy way to look. I've done a simple function here, but all the elements of my design recipe are here. I have a nice informative name. I have a contract with the user that it provides input about what's needed to go in. Notice I put in integers, but I could have put in something like that, right? Then I get something really close to 0, of course. And so that's called the type contract, if I recall. And then I have a little description, the call of the body of the function, and then the examples. I think the examples are really important. For example, what's going to happen if I go like this? Okay, I think you already know that's going to be an error. And look, I'd know, okay, well, I should be getting something awfully close to 0 for 32.002. And I'm not, I'm getting 14. So I know I made a mistake. So it's not only good for you to check, but it's good for the user to see kind of how the function should be called. Okay, so let's go back to notes. Let's just take a look at the two concept checks here. Whoop, went way too far there. So which of these components of the function is inconsistent with the other components? So notice we have, let's examine each component. I just realized I did not put the example in that when I just wrote the Fahrenheit to Celsius. I think of that more like the test. I kind of think this is optional. The author of this book always thought you should do an example, and that's great. I think there's nothing wrong with that. But here's the example. Given the type contract here, we put in integers, we get back a Boolean, okay? The header, well, there's our header. It's something that makes sense, sum 11. Description, yeah, returns a true if and only if those numbers sum to 11. And finally, the body, there's the body of our function. And indeed, it looks like we're just making a statement of num1, num2, num3 summing to 11. But remember, this is a comparison operator, so it'll return a Boolean object. So which one is inconsistent? Take a moment, pause, think about it. Well, you should look at the example here, because we should be getting back a Boolean. In fact, in the user contract, our type contract, it has back Boolean as our response, but we're getting back the actual value. So this is what you would have gotten had I not had there not been a test here for equality to 0, or equality to 11. We would have just gotten back the sum of the numbers. So that's the part inconsistent. Again, what's inconsistent with this one? Take a moment. Okay, so the type contract is telling us we put in an integer, get back a Boolean, and then the description says we return the rightmost digit of an A. Okay. There's our example. We're getting back the rightmost digit of 14, which is 4. There's our body, which is taking A, integer division 10, which makes sense. And there's our header, which says rightmost digit, so that makes a lot of sense as well. What is inconsistent here? It would have to be here, that type contract, right? Because it's telling us we get back a Boolean, which is not correct. We're getting back the rightmost digit. All right, I'm going to stop here. I am out of time almost. We'll pick this back up in a moment.